Good afternoon. Okay. Good afternoon, Stephanie. Good afternoon, Alyssa. Good afternoon, Andrew. Good afternoon, and hello, we, she. Good afternoon, Gabriella. Good afternoon, Vivian. Good afternoon, Brenda. Good afternoon, Nicholas. Good afternoon, Catherine. Good afternoon, Celine. Good afternoon, Warda. And I owe one of you, well, I owe many of you things, but okay. Good afternoon, direct message. Yes, I still owe you. Good afternoon, Jaylyn. I don't know what you're talking about, Gabrielle. Good afternoon, Lakshmi. I mean, I do, but I'm going to pretend it. Wait, there's more people. Okay. Wait, is that ready? So yes, I deserve that. Oh, wait. Oh, I wish it were gatekeeping. Believe. Okay, wait. Yes, no, that's funny. Believe me, I wish I were getting. No, it's because gatekeeping would be deliberately keeping you from information that I actually have. Okay, wait. So direct met. Okay, wait. So on this, okay. So there's a public question that Gabrielle's asking, but then there's some private chat questions too. So, all right, we'll get straight to it again. We only have a couple of classes left. I mean, literally a couple, including today. I'm horrifically aware of that. I always become aware of that a little later than normal human beings become aware of the passage of time. Like they say, those who can't do teach, and those who can't manage space and time teach physics. Actually, they don't say that, but now I'm saying it. So many of you have now gotten your 14 points back. Not all of you, most of you. Some of you have gotten your exams back. Many of you have still not. They are dribbling pathetically back to you one by one. I mean, the pathetic part, again, is me, not you. Hopefully, at least many of you have seen your 14 points or your 13 points if you didn't put a final answer or something like that. Hopefully that's a little bit of a nod to you to increase your confidence that this will all work out in the end. But right, I could see right now why you might not believe that. They're still going to just keep dribbling back. There's other logistics, and I apologize again. There are other logistics that I want to put in the Google Classroom. I'm just going to tell you quickly now, since I know we are starting to wrap up. One of the logistics, somebody just asked me in the private chat, partly because this is true anyway, or should be, but partly because of all the delays on my end. I'm certainly saying, if any of you guys still want to turn in for any points, if you're concerned at all, I mean, if you're concerned at all about your grade or things that you can do to help your grade, certainly any old homework or any old game turn like that, you have every right to still hand in and to expect that I will give you credit for, even if it's at the last minute, and even if, well, one more, hold on, sorry, let me, I think one more after today, I think we'll check that in a second, but I still owe you back a lot of points, like particularly on this exam. And I want to address this again today, like every day, because I know that what I'm doing is causing some anxiety, and I want to minimize that. First of all, yes, if there's any homework that you never turned in that you still want to, or any correction to homework that you still want to because you feel like the points might help you, yes, you certainly can up until Tuesday, which is the last day of classes. I was going to say Monday, our last class, but I don't care. You could turn it in Tuesday of next week. That's fine. Like anything you want to turn in 4 points, you can still do up till Tuesday because that's the least I can do. And you will get the points, even if you don't literally end up seeing lots of marks, or even if it's too late for like lots of helpful feedback, you'll get the points. And I understand that grades are grades. You will eventually get your exam score back, those of you who still haven't yet. And let me address that. And I'm going to put this in Google Classroom. I believe, and tell me, Stephanie's asking in the chat, tell me if I'm wrong. I believe we have today's class, which I would like to spend some time doing class material, and we have Monday. and I think that's it. But I think when Stephanie says one more class, I think we mean one more in addition to today. And I think I agree. But someone tell me if that's a different understanding. I think we have today and we have Monday. Yes. Okay. So then it also brings up, and I don't even know if I should be recording this or not, but like as far as grades, and final exam and all that, I will put this in the Google Classroom what I'm about to say, but let me try to be as clear as possible. Like let me back all the way up before I even get to the final exam and all that. I will tell you what I told the other section yesterday too. I will tell you that I know we're getting to the last minute and I know there's concerns about unknowns and things like that. I will tell you that as we approach the last class next week and as we approach the finals period, if I come to any belief or any reason, if I'm looking through stuff and catching myself up, if for any one of you, if I look at your situation and I'm suddenly like, oh my God, I did not realize this before, but looking at her midterm right now, or looking at his midterm or whatever, oh, this person actually could really get like a C- in this class, right? If I think that's true, I will reach out to you personally and say, we might have a situation here. Let's see what we can do to rectify. Like, is there other homework that you could still hand in? Or can we make sure that you know that you really need to get an 80 on the final or something like that? Okay, so first of all, what I'm telling you all is if I start to believe that your grade might be like in the C range or lower, I will reach out to you and let you know that I think that there's going to be an issue, and it'll give you time to try to rectify it with me. That's number one. Right. So basically what I am saying, I mean, even though this is like a dangerous thing for me to say, I am saying, I am saying what Nicholas is saying. I mean, I'll put it in my words, but I'm saying, because I know that unknown worries people for good reason. I am saying that, and we do have to have a final exam, and we will. I'm going to explain that in a second, but it's going to be meant to help your grade. I'll explain that in a second. But I am saying that as we sail into that period, to the next week period, and to the end of stuff, if you don't hear from me at all, yes, I like one of two things. One, if you think you're okay and you don't hear from me, then I think you should assume you're okay. That doesn't mean a guaranteed A. Like, we're not getting A's as gifts or whatever, but it means I think you're okay. And it means like the worst surprise that someone's going to get, the worst surprise that someone's going to have, if it turns out they really did do really work badly on the midterm or on the final or something, is like maybe someone thinks they're about to get an A and they might end up in the B's or something like that. And I'll address that too in a minute. Like, I don't consider a B in science like such a bad thing, but I know some of you are used to very, very high grades and stuff. But so I'm not going to reach out to each and every one of you if I even think there might be a B in your life. But if you don't hear from me, certainly I think it's fair to assume if you don't hear from me, you should assume, okay, you're probably at least in B range. You're not going to suddenly be surprised with a C. That's number one, to address what Nicholas is saying. I'm also saying, if you do have concern, like if in your heart of hearts, you're like, yeah, he's saying all this now, but I didn't get my midterm back. And I know in my heart of hearts, I totally trounced that midterm. Like, I don't know what he thinks he's talking about. Yeah, but I think, then please do reach out to me personally between now and the end. I might not be able to deal with it. Like, one person already has, and just wants to know, like, wait, I'm like really nervous. Can you give me more information? I totally respect that. I wish I had given you all more. I'm not trying to gatekeep, believe me. So I'm saying, but I know that I inadvertently am. So I am saying, I consider C's and below things that I'd want to know about in advance if I thought that was going to happen to me. And I'm saying if I detect that with any one of you, I will reach out. But similarly, if you think there's something that maybe you know that I don't know yet, or you just think you're a little bit, or you're just nervous, reach out to me and I'll sit down and see what's what with you, and we'll see what's what. Okay, that is not a promise that nobody's getting a C. I'm not saying that. I'm just saying I do know that just suddenly being surprised by a C with no chance to do anything about it is like the nightmare that none of us wants. Okay, so I am saying if you're nervous at all, reach out to me, like not right now, but reach out to me and we'll see what's going on. If I'm nervous about your situation, I will reach out to you. Okay, I am saying all that. I'm also saying now about, well, yes, private chat person, they're true, but totally private chat person, or that actually there's a lot in the private chat. Oh yeah. Okay. So yes, like there's a lot happening in the private chat. So I'll try to answer it one by one. I'm always nervous about recording these kind of classes, but I am going on record with you saying whatever I'm saying here. Like I'm also saying this, there is going to be a final exam because there has to be, and a final summative experience, but this all, it will be a lot shorter than the midterm. And again, what I'm saying is, like, I will weight more heavily. Like if you did really well on the midterm, including those 14 points, which I'll address again, then then the final will not count as much for you. I mean, I still have to count it. I'm not, again, the grade you get in the end is not going to be a gift. It's not going to just be like a charity, like a contribution. You will have earned your grade. But what I'm really saying to all of you, always, my philosophy is you give me something to work with. You give me something to work with. And what I'm ultimately really saying, and I'll say this like in any court of grades or any whatever publicly, I'm saying that I don't believe anybody should be graded on their middle. I think they should be graded on their best. That's what I honestly believe is there's more than one ways to do an average. There's more than one way to take a whole bunch of data and turn it into a general conclusion. And what I really feel absolutely professionally is there's no law from Moses or anything else that says that your final grade in the class should be entirely based on just literally the arithmetic mean of what you do on like a boring middle of the road day. I think we have good days and bad days. And what I think you should be graded on largely or more largely is what you showed when you showed your best. I mean, that's so what I'm really saying to all of you is you give me something to work with, give me enough work or evidence to show that you strike me as a person capable of A, physics work, and we'll say you did A, physics work. So what does that mean? It means, yes, of your two exams, the midterm and the final, I will weight more heavily the one that you did better on. We're both looking for ways to understand you at your best. That's what I'm saying. So some grades will still end up being bad. For example, there are some people that are not even in the room right now, not even hearing this speech. Those people, perhaps, are the ones that are going to help out whatever larger curve needs to happen to show that a grade is something that you actually earn, not something that you're just given. Anyway, I'm still going to answer more. So to answer one of these questions in the direct chat, yes, the 14 points that you got for doing that extra kind of thing are added directly to your midterm score, even if you don't still have a midterm score directly. So if you got a 68 on the midterm, you got an 82 on the midterm, but then you got the 14 on that thing, then you got an 82. Yes, I'm definitely saying that. No problem, direct chat person. Okay. And again, all the points that you've ever like gotten for any game turns and all that stuff all counts in the end. And now what's the final going to look like? I want to wrap up this material and have you see a conclusion at the end of this course. Like that's really my most important priority, that you see a punchline and a purpose to all this material. We have 2 classes or a class and a half left in which to do that. On Tuesday, I will put this all together for, not Tuesday, on Monday, on our last class, I'll be putting together all the material for one last final time. And there will be one short final kind of thing that I'll address on Monday. There will be a short test document that will be posted. That will be posted. Hold on, sorry, it will be posted, and I'll put this in Google Classroom, but it'll be posted like Wednesday night, a take-home final exercise. It'll be due back to me the following Monday, because I believe the following Tuesday is the last day of finals, right? So you'll have a week to do it. Again, it'll be shorter than the last thing. We'll discuss it explicitly Monday in class. I may post like a practice review document before Monday in class, but I might not, because my first priority is to still finish all these numbers and get them back to you. But Monday in class, we'll discuss this final opportunity to synthesize the material. You'll take it home and you'll hand it in the next Monday. again, and I'll grade that, and whichever you do better on will count more. And again, what we're looking for, I mean, I'll say this bluntly again, I'm looking for you all to get B's and A's, and mostly A's. That's what I want. That's what you want. Again, I would have no problem if every single person in this class ended up getting an A because the numbers actually worked out for them based on these methods. Great. But the numbers do have to work out, of course. So some people will get B's. If you think, or I think, as we approach next week, that there's a severe chance that somehow you're in trouble and really might be getting a C, not that that's a crisis, but if we think that, then we'll discuss it in advance and see what we can do. And then also, okay. Yeah, I mean, honestly, what Gabrielle's saying, wait, did I? Oh, okay, thank you. Wait, hold on, I'm just looking at the private chat. The final will basically be one, it might be two, but basically it's going to be one or two questions. And I don't know, at this point in my life, I don't even know what constitutes easy, but I will say will not be as involved or as intricate as the last thing. And it'll be an opportunity to put the big ideas together. And look, again, let's be honest, it has to be something that's sort of straightforward that won't take me months and months and months to go through. Otherwise, you'll never get a grade, right? So we're both on the same page with that. Okay, I will try to only use, that's unfortunately, I think what I usually use, but yes, the final will be meant again as an opportunity for everybody to put these things together and get one more final number. Okay, but I want to put these things together. So I do want to get, so again, I'm just, some of right now, I'm like rationalizing and making excuses for myself because I know it's bad that you're missing this key number that would really ease your uncertainty a lot. I totally sympathize with that. And I really do apologize, but I'm telling you that I will be well aware of the inconvenience that I put you through when I sit down to do all these numbers at the end. Believe me. And I'm well aware of all the work that all of you have done throughout this whole semester, and in some cases 2 semesters. Okay. Also, I want to say one more time before I forget, just what, I mean, as we start wrapping up, and there is material to wrap up, but one more time too, one of the other reasons I feel bad about all this, and I do think it's going to work out for all of you and all that, but I really have enjoyed you very much as a group, and I'm very impressed by you, and I'm very glad that I got to know a number of you more in person than I ever expected, which is great. So I do want to just reinforce one last time that I'm sad this is the last course in which I'll see you people. Like back in the day, we had a physics 382. I wish we still had that to see you again. We don't, but I really hope, and I mean this specifically, many to you as a group, I hope that you track me down after the semester, or you remember me when it is, and many of you already have, when it is time for graduate school applications or job applications, or in some cases, many of you have already done this, or honors applications or summer applications. I hope I would be honored and delighted to write support letters for you. I take that very seriously. They usually work. I feel like I have a lot of very specific things that I can say about many of you, and particularly impressive specific things that I could say given the constraint, I mean, especially in light of COVID and all of that, where it's become very hard for people to get to know other people and very hard for many people to stay afloat. It does not escape my attention how much you guys really have stayed afloat. And I really, more than me, obviously, or more than I have, clearly. And so I hope to be able to continue to support you after this in your future endeavors, really. And I hope to see you after. Okay. No, and I really mean that. Oh, why is this? Sorry. Okay. No, and again, you've all seen, I mean, I also moonlight at this other place that has younger students, and you all know I have a 7-year-old and an 18-year-old. The world is tanking in school right now. Everybody's tanking. You guys are the survivors. You're sitting here still in your second. I mean, if you're here at all, you are surviving. And you know that. Okay, I'm going to move on in a second. But once I get on this topic of how impressed I am by you guys, I really could go on forever. And I hope you know it really is sincere. And by the way, those of you who might think, oh yeah, well, he always gives that speech, and he gives that speech to who's ever sitting there. He always loves everybody or whatever who's sitting there. That's true and that's false. Just so you know, am I more full of love than hate? for students, yes, I like to think so. But if you think that you always hear this speech, or that I'm always giving the speech of how wonderful you are and how great you are and what survivors you are and how plugged in you are, remember for a minute that you're already part of a self-selected crowd. If you think you're hearing the speech a lot from me, it's because you're here a lot, listening a lot. Like really, really, I'm talking to those of you who are here listening to me. That ain't no coincidence, and that ain't no large group. Like a lot of the people I'm not talking to them are the people that are falling by the wayside every moment. And I sympathize with them, but they are not you if you're hearing me right now. Follow? So it is a little bit of a circular thing, but it's totally true. Two last things I'll say about that, because I need to make this speech all the time, because I think this science program is really hard. Many of you have heard me say this before. I cannot say it enough. I want you to know that I know that. I think I did some hard intellectual things in my life, some hard academic things. I think this program, and I did some expensive things, but I've been to a ritzy private school for an undergrad, and I've been at CUNY, among other places, for my grad. I've experienced them both. I have never experienced them both at the same time, which is what you guys are, whether you know it or not. You're experiencing all the challenges of a classic liberal arts science program as per like private ritzy schools. You're also experiencing all the challenges of a public university, like real life practical job training program. You're experiencing both at the same time. Very few schools do that. No school I ever went to did that. I don't know if I'd survive this program. And I'm saying that, and as you can see, I barely survive it as a teacher. But really, I want to get off this horse and get back to physics, but I need you to know, especially because I think I add some anxiety to some of your lives. I know how anxious this program can make people. And I'm totally impressed with anybody who gets through this program. And please always remember that I may give this speech to you people all the time. I don't say it about every program in the world or every program at John Jay. Not every major, not every program, not every department is actually a department where if you get at the end to the other side, you do necessarily deserve or should expect great graduate school or great job opportunities. Not every program. This one is. Why? For the reason that we all know. The simple reason that not everybody makes it through this program. The mere controversial fact that more people start than finish and believe, and those numbers are tracked all the time. And a lot of people find those numbers very upsetting. A lot of people think it's like scandalous how many people don't finish this program. But I'm here to tell you that right there is why people know that if you get a degree from this program, and I mean either one, I mean mobile or forensic science, and even if you're like on an e-permit, these kind of programs, anybody who's in my class right now, if you've made it this far, you're trying to get a degree from a program that a lot of people start and don't finish. By definition, that means that when you get that degree, people know it's not a joke and it's not a gift. And it's the same thing with an A in this class. You might even think at the end that there's generosity or something like that. But the reason that some of you can get an A in this class, or many of you, is because you finish it. And the reason that is a standard is because many people don't, right? Therefore, really, that's what means that what you're doing is real, that it's actually possible to not do it. Therefore, if you do it, you've endured something real. And therefore, my last thing on this speech, I know I've said it before, but I hope you're all hearing me. Therefore, please know that there is almost no one ever who has gone through this program who hasn't had at least a moment at one point where they're like, oh my God, I don't think I can make it. I don't think I'm cut out for this. I don't think I'm the one. I don't think I have what it takes. I don't think I belong here. Or the slightly more cocky version, I totally do belong here. I totally do have what it takes, but is this really worth it? Is this really worth it? Like I'm giving up every weekend while everybody else is partying, blah, 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 blah. Everybody has at least one moment when they're like, should I really go on in this thing? Everybody, when you have that moment, do not think, the mere fact that I'm even having this moment is like question answered. Like if I'm even doubting myself, that must mean, because everybody else looks confident, everybody else looks like they belong here, blah, 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 blah. If I'm even wondering this, I'm having a crisis. People that are meant to be scientists don't have crisis. Don't believe that. Nobody goes through this thing without having a moment, without having at least one moment. And it often does happen. Sometimes it happens before physics, during physics. Often it happens in your next semester, during instrumental or during PChem or whatever, biochem. You'll have that moment where you're like, oh, wait, is this really? Should I really? Wait, can I really? And I'm here to tell you that the difference between the people that get the degree and the people that don't is simply the difference between people who after that moment go, it's okay. It's okay. I'm just going to go for it. What the hell? I'm just going to close my eyes and have faith in myself and this whole deal and just assume that if the people around me can do it, I can do it. Those are the people that make it. Like the special thing is keeping on going through that moment of crisis and not assuming that the moment of crisis means you don't belong. Assume it means you've now joined the club. And the next move is just to keep going, really. And the joke is, and then I'm done, you know the old joke, I'm sure you all know the old joke, it's an analogy to this, but it's a joke, is what, I think I've even asked you this before, what do they call the person who graduates last in her class at medical school? Like, I'm just gonna look, do you know? Like, what do they call the person who graduates last in her or his class in medical school? Do you know? Any guesses? And then I'll go, I don't know if I've lost you all in this whole thing, but exactly. They call her doctor, right? And you get it, right? And same thing here. It's about finishing. I mean, you can finish with a lot of accolades and a lot of awards, and that's great too, but not everybody does. And it's not just the people that do that belong here. And okay, anyway, and yes, do you all deserve? Yeah, so basically the people that, yeah, you do deserve it, but you have to actually prove that you deserve it to get it, and you will. Okay, enough of that, sorry. All right, so let's go back to physics. But if there are any questions, put them in the chat. But yes, I will miss you, I'm sad. Oh, okay, wait. Okay. Oh, good, no, I'm glad, okay. Oh, good, okay, no, I'm glad, wait. Oh my God, okay, wait. Oh, cool. Okay. No, I appreciate your appreciation. No, and I'm glad. I mean, I never know if that's like a waste of, no, and I really mean it. And please, guys, like I've been doing this kind of work, right? For like literally, I've been doing this for longer than you've been alive, which is so weird, right? Like literally, one form or another of physics teaching since 1992, but this thing at John Jay for like 12 years. And guys, no, seriously, like and COVID, oh my God, like you're still here, you're standing it to everybody else is a mess. If you do it at all, you're the cream that rises to the top. Like really, really. Also, last thing, like look at what a mess I am. I'm sure you all could see that. I'm a total freaking mess. If I can get this job, right? And it's a dream job for me. I feel totally blessed having this job. But if I could somehow work this out, you guys can work this out for real. But okay, I'm going back to okay. Wait, I'm going to here. Okay, and change of view. I'm going back to physics. Okay. But thank you for listening and thank you for your indulgence. Okay. Okay. Oh, chat. I'm looking at the chat. Oh, and I hope I addressed everything in the chat. I don't know. Oh my God. Okay. I guess I have to accept what Gabrielle said. That's a very obscure. Okay. Okay. But yeah, fair enough. I'll accept that. Okay. So the question of the last two classes, here's what I want to address. My goal is to address the issue of updates to the electrostatic field. As of last class, when I was starting to ask you to I was starting to try to ask you to picture electric field lines. The way we want to picture the electric field now is through this mechanism of field lines. Like, again, the lines are based on vectors, right? The original picture of a field, the original concept of a field is it's like a function. It's a vector valued function. A field is a function whose input, whose domain, whose independent variable is the 3 coordinates of space, and whose output is a force per unit charge, newtons per coulomb, right? So, or more specifically, whose input is a location in space, and whose output is a vector at that point in space, indicating how hard and in what direction a hypothetical unit of positive charge would be pushed or pulled, right? So first, when we picture the field, we say first we picture empty space. Space is empty. Then we imagine some object being in that empty space, like a proton. And we say that the proton deposits information appertaining to it everywhere in space. Specifically, it deposits its size and its location everywhere in space. And it does so by placing, arguably metaphorically, a little arrow at every point in space. And the arrow sort of points to the proton or points away from the proton, and the size of the arrow indicates how big or how many protons are actually there. That's like our first picture, right? So one way always to picture a field is to picture arrows everywhere, and to picture the field as like a rule, a mapping. You name the spot, we supply an arrow. What does the arrow mean? It means the magnitude and direction of force that would be exerted on some unit test charge due to the original source charge that created all these arrows, right? And so we assume that every object that gets put in space creates its own array of arrows. Then we start saying, well, if every object that's put in space makes all these arrows, and 2 objects together can make a whole bunch of arrows, and 3, or a disk of, then it's going to start to be hard to picture all these arrows and to let alone to draw them. So that we develop our picture, make a sort of smoother picture of this whole idea. And the picture involves sewing up the arrows and connecting with something called field lines. So now we picture space as field lines. And I gave you these rules for how to draw field lines. And I showed you, or we looked at like different examples of basic field line diagrams. Now I want to just summarize what those lines are doing in one more sort of concise statement. So my ultimate goal is I want by the end of the next 2 classes, I want to look at what does it mean if the field lines represent the information that's in space, the information that is over here, describing what's actually going on or present over there. Right. And let me say that one more time. Let me just reinforce. Again, the whole idea of the field is it's by virtue of the field that at one location in space here, we have access to what the size and the location of any object that might be at some other location of space over there. Right. The field is the container or the mechanism for information describing one location of space to be accessible to any other location in space. That's what the field is, right? Well, my ultimate goal is to investigate with you over the next 2 classes to figure out, well, what happens when we change the field? What happens when we change, like when one object moves to a new location or one object grows? What happens? Like, how do we update this whole array of information? That's my goal for the next 2 classes. And put another way, what I'm really saying is, My real question is, can we develop a mental picture of what happens to the field lines when changes occur in space? Okay, in order to do that, I want to give you one more way to understand fields, or one more sort of large description that must always be true of fields, or field lines in particular. Okay, here's a big point. Well, let me read this out loud. I'll tell you why I'm saying this. So I'm saying field lines convey information regarding one point in space to any and every other point in space. I mean, it's a little bit clunky, but right. So what field lines are is a just field over here. If I'm a little proton over here, a little test charge, I look at the field lines, and from the field lines in the region that I'm in, I can tell what's going on over there. That's the whole idea. I mean, I can also tell what's going on over there or over there. The pattern of field lines is telling me what's going on in other points in space. And when I say very good. Wait a minute, let me get this chat. I see. Yeah. Sorry, this is a direct chat, but in the direct chat, someone's asking, what do I mean by source? Great question. So by source, I mean very literally, and that's a very concrete, very good question. By source, I mean the thing causing the field. So like in all of our examples, if we have the field lines coming out of one proton, we call that one proton the point source. Or if we have the field lines coming into an electron, we call the electron the source. The source originally If you remember originally, a force is always an interaction between two objects. Like a force is like, I push you. If I push you, we could say that I'm the pusher and you're the pushee. In the language of all of this, we would say I'm the source of the push, and we might say that you're the receiver of the push. But what we end up saying in this language is that, so with charges, if a proton is pushing on an electron, what we say is that the proton is the source. It creates a field. And a field is all the information of what would happen to any test object that might be placed in the field. So the source is the doer, the test is the receiver or the experiencer or whatever. And we call it a test because of the whole idea that it doesn't actually have to be there in order for the field information to be there, right? So a force is I push you. A field is I push space. And now if you come along and land in space, then space pushes you, right? So the source is the cause of the field. By source, I mean whatever proton or electron or configuration of protons and electrons, whatever bunch of net charge is causing the field is what I mean by source. Okay, so maybe let me know in the thing, the direct header for that answer to that question. So source is like the dot at the center of all the, or the dot at the center of the pictures that I was drawing yesterday or 2 days ago. And in all the field line diagrams that we were looking at in Google Images the other day, like, so for example, there was a field line diagram of like a dipole, like a plus and a minus next to each other. Then that assembly, the plus and the minus, the hydrogen atom, that would be considered the source. Okay, fair enough. Okay. So what I'm saying here is that field lines are the way that we can tell over here what's going on over there. Now, how do they and always go to everybody when you're trying to understand these abstractions that I'm saying, always in your mind, picture the simplest possible case and build from there. Like I'm saying, for example, if all of space is blank, it's empty. If I put a proton, like one point source of positive charge, I put one down, like some right here, right? What does the proton do? It creates field lines that radiate out in all directions, right? Because it's 1 point, it radiates out in all directions. The whole idea of that is that if I go to some location somewhere else in space, and if I imagine a positive unit test charge sitting in space, like that unit test charge is like on a field line that's pushing it that way, and that's very far away from the other field lines. Like that test charge right there, or that meter or that instrument that we put at that location at space would in effect seize this field line and can tell, or sees this bunch of field lines that it's in, and it can tell, oh, the field lines aren't very dense right here, so I guess the field is very weak. And oh, the field lines are like, if I trace back the field lines, they all seem to be coming from this point over here. So, oh, there's a proton over there. Like the whole idea of the field lines is that their density indicates magnitude and their orientation indicates direction. So if you're somewhere in the field, you can intercalate like what's going on somewhere else by looking at the pattern of the lines. That's the whole idea of them. So the field lines tell this part of space what's going on in that part of space. Now, specifically, if you look at those, and maybe I should, yeah, I'm gonna put the pictures back up again. Hold on a second, sorry. Hold on, bear with me for 1 second. Right. Okay, so let's look at the bar. I forget which the bar back diagram is, but here I'm about to share my screen. Hold on. Hold on, coming. Sorry. Come on, sorry. Okay. So I'm going to share my screen. Yes, I'm going to share my screen. Hold on one second. Okay, so just, I mean, these are like random, I mean, this is not like some highly sophisticated search that I just did, but just, these are three, you can see this, right? Yeah, these are three typical field line diagrams. And the more you get used to everything I'm trying to tell you about field lines, like the more you can tell, like what's going on in the center diagram is two equal positive charges, right? And that's the impact that they're having on the universe, on all the space around them, is as depicted by that second diagram. The whole idea is that if you were, I'm looking at the chat, sorry. If you, Oh, I see what you're saying. Yeah, no, we're done with the barbaric diagram. Sorry. I don't know what to tell you about that. Well, actually, we're not done with it, but we might get back to it. But right now, we're on these diagrams. If you look at the center one for a second, like the idea is that can you see my cursor? Oh, you can. Okay, so here's my cursor. If you we're just this point in space, like right here where that arrow tip is, the whole idea is that if you were just there in space and you looked at the surrounding regions of lines that you were in, you could tell, oh, those lines are not very dense. They're not comparatively dense. So I'm in a comparatively weak field, but look where the lines are pointing. The idea is if you really sat down and did the math or whatever, you would understand that there's a positive charge here and a positive charge here creating those field lines, because in the same way that the two blue positives create that field picture is the picture that would be caused only by two blue positives. So if you're in that point in space and you really know your diagrams, if you're in those field lines, you would know that there's two positive charges separated by a certain distance and a certain distance away. Now, of course, this is all a metaphor. I'm not saying that literally there are literally lines in space or that space is sitting there literally doing the calculation. But what I'm saying is that this is a representation of the fact that the information of these two positive charges is embodied in this point right here in space. I'm looking at the chat. Sorry. Okay, that's funny. I'm just going to ignore that, but that's funny. Okay, but now, like the pattern of the lines are always in a pattern. The pattern captures is like written according to a number of rules. The pattern captures the pattern of the thing that causes it, right? Like these three pictures are very different because each one of them is patterned. Each one of them is you can see a certain pattern. You can see a certain organization to the lines in each one, but it's a different organization in each one because the thing that's causing each one is a differently organized source. All the way to the left is a dipole, like equal and opposite charges. All the way to the right is opposite, but not equal charges. You can tell from what the lines are doing that the positive charge you can tell, well, you tell me actually. I'm almost afraid to ask this, but in the diagram all the way to the right, it's caused by two opposite charges, but one of them is like many more coulombs of charge than the other. Can you tell? Can you tell me like which is a positive or the negative stronger in the diagram all the way to the right? Awesome. I'm psyched. I should probably give you all more time for more people to answer, but yeah, I'm totally psyched, and I'm psyched that it's not. That's funny. Yeah. No, that's good. We, she, and Nick, Alyssa. Yes. Like, well, okay, how about somebody else? No, they're correct. Can anybody else who wants to, and I'm watching the time, I know we're getting, but can anybody else who's like not Nicholas or Rishi say why they said that? Okay, that's funny. That's funny. But could someone, how did they know? How did Rishi and how did Nicholas and Gabriella know that the positive is the stronger charge? Okay. All right. I mean, my God, she's like, I think, I mean, you know why? Okay. She lives in a metaphor. I want to get out my translucent umbrellas because it's like a metaphor shower coming. But yes, 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 they are correct. Like the reason they know that the positive charge is stronger, is a bigger charge than the negative, is because there's more lines coming out. The lines, the number of lines per unit area is higher. The density of lines is higher around the positive. Now, wait, what's my point with all of this? I'm trying to say that these lines are the way that space, like over here, knows what's going on over here, or space over here knows what's going on over there, et cetera, et cetera. Notice this though. It's all, even though they get very elaborate and very complicated, like for sure, like the more, like you see, the more, well, okay, that's pretty complicated. The more, oh, that's pretty complicated. The more complicated the thing is that's causing the field, certainly the more complicated the field. But notice there's always a certain base simplicity or a base smoothness or symmetry to the field. In other words, this is the thing I was trying to say in my notes a second ago. What I'm trying to say is the way the field lines convey information is what they're really conveying is difference. What they're really conveying is asymmetry. Then this is a very kind of deep point. And I want you all to be listening. I know we're not doing a lot of math equations now, and we're not for the next 2 days. I'm really trying to put this material together for you in a conceptual way, and that's what you're going to largely do for me in the final document. Okay, for whatever it's worth. This is not a side tangent. I know I'm like yelling in English, and for some of you that's good, and for some of you it's bad. But just so you know, we're going to be talking. I'm trying to put together a conceptual picture for you of everything we've done for the last 2 days, and that's what you're going to try in a reasonable, mellow, non-stressful fashion to do for me in the final. It's not going to be a ton of equations for whatever it's worth. So I don't know if that means you should be taking this. So don't think that just because we're talking like this, that like this isn't the material. It is the material. What I'm trying to say right now. And also for some of you, this material is much easier than math, I know. And for some of you, this may be even like weirder and harder to get your mind around. I don't know, but it's reality. The reality is this. The reality is that I'm checking the chat. The reality is you'll draw some, that's a fair question. You'll draw a little bit on the final, you will, not crazy things like this. I will ask you to draw a little bit on the final. I'll probably ask you more to interpret drawings. Yes, you will have to draw a little bit, but nothing as crazy as what we're looking at right now. But that's a fair question. And I'll be more detailed in my answer to that on Monday in the last class. And possibly in things I'll put in Google Classroom before. But here's what I want you all to know. And here's the thing, field line diagrams seem like they would be really hard to draw. They certainly seem that way, and they seem that way to me forever. But they're not as hard to draw as they look, because the whole idea is this: space itself, if there's nothing in space, space is as symmetric as symmetry gets. Space is the same in every direction. Space is the same in every chunk, like in every subspace, i.e. space is isotropic and space is homogeneous. Space is like the essence of sameness. It doesn't get any more same as space is to itself, right? But then you and so if there's no objects in space, the field line picture of space is as uniform and simple and as patterned as it could be, which is to say no lines at all. Then you put one dot in space and you get these lines coming out from the dots. You just get these, like if you put one proton in space, you get radial lines going everywhere. Now those radial lines are as simple. Think about it. They're a total simple pattern. They're going the same, they're going on forever, the same way in every direction. They're as simple as lines could be, given that there's a dot that just interrupted the symmetry of space. Like what those lines are telling all the rest of space is, yo, trace us back, trace us back. Trace us back as we get more and more dense. You're getting closer and closer to the thing. Oh, if you trace us back, wherever you are, trace us back. There's a dot over there in space, yo, right? Like if you think about it, those lines, that pattern, like a starburst of lines, is only as asymmetric as the fact, as the thing that caused them, they're as symmetric as they could be, given that there's a dot in the otherwise smooth, perfect symmetry of space. Do you follow what I'm saying? Like I'm saying, how do those lines tell us that there's a dot in space? They indicate it by virtue of their asymmetry. The way in which they're not all the same, the way in which they're diverging from a point is what tells us that there's a point. Let me go one step further. I know it's 1:15 when I look in the chat. I almost have a feeling. Wait, good question. In the private chat, someone's asking, is this all physical or is it theoretical? Like, are these physical objects just extremely, extremely tiny? Very fair question. The thing that I'm trying to say over and over, this is not just theoretical. This is real. It's physical, but it is not particular. Like these field lines are as real and as physical as sound is. Do what you want with that. I mean, I'm not being sarcastic. Like this is sort of the point of the whole course. Like these lines are real in the sense that something real is sitting in space. But what's the real thing that's sitting in space? Information. These lines themselves are our representation of that information. I am not actually saying that there's granule like etchings in space. And I'm not being sarcastic. It's a very important question. And it's a very dicey, but this is what's so powerful and conceptually deep about this material is I'm saying they're freaking real. Oh, they're real. I mean, if sound is real, these things are real, but sound is not an object, right? Like you just get your mouth, right? I mean, and I'm not saying these are sound. I'm making an analogy, but it's not a coincidence that, well, okay, well, except that may be, but well, I don't know what to say about that. All right. Yeah. I mean, it's taken me a lifetime to buy this, but look, okay, I'll read the one last thing that someone in the direct chat is saying because it's valuable, but I also want to say the person in the direct chat is saying this is hard for me to buy. I'm going to need more time than just one more class. That is sort of very fair. I mean, super fair. Like sure. But on the other hand, I want to make it clear, this is not just one more class. It's not just the one more class that is in support of you buying this. It's all the classes before this one. All of the classes that we've been doing are meant to get us all to the point of seeing how to get our minds around this. And of course, you can't immediately get your mind around it. No, I mean, I want to give you a final exam or whatever that will give you something to take away and think about when you leave, for sure. But let me say to all of you, the whole point, like this class is an exercise in increasing steps of abstraction, which is why it's hard even when it shouldn't be hard, and why it's easy even when it shouldn't be. Like all we're trying to do in this class is build from tangible, accessible, chunky objects that we feel like we can picture, like planets and springs. We're trying to move our minds in increasing steps of abstractions to more and more immaterial things that do really exist in the physical world. And sound waves were like the big bridge to this. I mean, I don't want to get too, but right, of course, I'm asking you all to believe in and get your mind around immaterial entities, but that's why we've taken a whole class to do it. And yeah, to end, it's taken me 30 years to really to work out this way of talking about it to everybody. Of course, this is, I mean, the mere fact that someone in the direct chat is saying, like, I'm not sure if I buy this, of course, it makes me slightly defensive, but really, nobody should just immediately, right, that's funny. Nobody, and I'll address that in a second too. If anything I'm saying seems too obvious and too like, duh, yeah, of course, then I don't think people are paying attention. If any of you is kind of like, I'm with him, but I'm not like totally with him, good, then you're with me. This is dicey stuff. I mean, this is fields. This is the reason physics is hard, not the freaking math. The math is the easy part of physics, honestly, to all of us, even those of us who don't like math. Like the computations are the comfort zone. The tricky part that makes physics different is these concepts. But the whole class is an attempt to get you to not necessarily to believe me or to necessarily be convinced by me, but to see how it might make sense that I believe myself, not just because I'm accepting it on blind faith. Like there is a logical progression to these ideas. And always go back to in your mind, do you believe in sound? Like, I'm not saying that's the end of the discussion, but that's the center of the discussion. Do you believe that sound is real? And does it help you believe it, that it actually travels at a measurable speed and at a predictable speed and blah, 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 blah. Like, because the bottom line is whatever you believe is happening that's going from my mouth to your ears is, I think it's real. I think we've looked at all this math to see that it's real, but I don't think that it's a thing. And I don't think you do either. Whoever you are, all of you, right? I think it involves the motion of things called air molecules, but I don't think any air molecule is going from my mouth and blah, 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 right? So now I'm saying fields are even more abstract than that, but it's just the next, anyway. So yes, I'm saying to you all that these field lines are real. They're not literally made of charcoal, but they're there. And yes, you can believe it. Okay, but wait. Okay, but no, yeah, okay. There's a lot going on in the direct chat, but I will ask you to just like hold it for a second or let it sink in because again, I'm not saying this out of nowhere. All this is coming from everything that's happened before in the class. Like it's not like anyway, and I can talk to you probably more after, but you should let it sink in too. Like, of course, it's not just instantaneously. But also a lot of these arguments that I were making for why to believe it were in prior classes where some people were there and some people weren't. I'm just saying. But okay. Okay. So getting we have 10 minutes. But it's nothing. I'm not trying to. I like the questions that are coming in the direct chat. I'm going to have to ignore the last one just to get back. But again, of course, I think I'm saying something. I think I'm saying something tricky enough to be worth thinking about, right? I don't think any of this is self-evident. So if you're bothered by anything what I'm saying, then also that means you are hearing me. That means you're getting the weirdness of what I'm saying. So that's also good. But okay, the thing that I want to say right now with 10 minutes left, the key thing I want to say is space itself would be symmetric. Anything that you put in space introduces some level of asymmetry in space. The field lines caused by anything you put in space capture the asymmetry of what you put in space. So what I'm really saying is if you look at any of these field line pictures, no matter how complicated they look, they're always somewhat patterned and somewhat simple because space itself is still space. Like we begin with the notion of symmetry and then we begin with just picturing like the simplest thing would just be a bunch of horizontal lines or something like that, a uniform field. But then anything that we put into space is going to be somewhat non-uniform. So we'll introduce some kind of non-uniformity in that pattern. But we start with simplicity and we just keep tweaking. So I'm saying that the more complicated a field line picture, the more asymmetric a field line picture, the more asymmetric the thing must have been that caused it. And more specifically, whatever asymmetries you find in a picture indicate specifically and particularly asymmetries in the thing that caused it. So the converse of what I'm saying is field lines are always as symmetric as they can be. They're leaning towards symmetry. They will only be as asymmetric as they have to be to capture, to convey the information of whatever's causing them. That said, I'm pausing for a second to see how much I can do in 8 minutes with this. That said, the real question is like, what happens or how does it work or what happens to these lines when we change something, when we make a change? Also, please remember, that's what sort of prompted this whole discussion in the first place. Remember, this is all coming from and maybe this will slightly address the private chat person's question. Remember, the only reason I believe in, not the only, the original motivating driving reason that I believe in fields in the first place is because I have this knowledge, I have this empirical knowledge that, like, the sun, for example, pulls on the earth, and more specific through empty space. But specifically, we have this like GMM over R squared prediction that always turns out to be true, that such, according to which it's not just that the sun pulls on the earth, but the sun pulls on the earth with a certain number of measurable, calculable, predictable newtons that is fully determined by how far away the earth is, right? So when the earth moves closer, somehow the sun starts pulling harder, and that's just observed. That's not, I'm not asking you to believe, like, that's not a theory, that's just reality, that when the earth is closer to the sun pulls harder on the earth in precise mathematical way, GMM over R squared. So it raises the question was, wait a second, how did the sun like find out that the earth was closer? If it's still not touching it, if it's still across empty space, how does the sun get the information that the earth has moved and then adjust its force accordingly? Like, that's where this whole thing begins, is with that sort of question. So that's the question I want to come back to now. And I know I only have 6 minutes, but with the 6 minutes left and the hour and a half, hour and 15 minutes on Monday, my real question is, okay, now we got this whole, we started believing in fields. Fields were like the mechanism or the medium that holds the information describing the earth, and it holds it everywhere in space. So the sun is over here in that field and has the information describing the earth. And again, that's all. Like, and again, also get to the private chat person, everybody else. I mean, even when I just said that, don't I think that what I just said sounds a little bit insane? Of course. You don't have to picture it exactly the way I'm asking you to picture it. This whole business with lines and feel like, of course, that's a metaphor. Of course, it's a model, just like everything in science. It's a way in my mind of holding together what seems to be happening out there. Do I really literally know what is happening out there? Of course not. I'm just trying to come up with a mental picture that will allow me to make the most accurate predictions of what seems to be happening out there. So when I say, like, the earth is sitting in a bunch of field lines created by the sun, again, I'm not literally asking you to literally believe in charcoal lines that are drawn in space, but I am saying, I'm saying something about lines. I've got to picture something that makes sense, some coherent model that allows me to predict, because what I do know for a fact is evidently when the earth comes closer to the sun pulls harder on it. So something is going on. If you can come up with a better, and this is not sarcastic and it's not just, but to all of you, if you could come up with another picture that works better for you than the words I'm using, God, quark, bless America. But I'll suggest to you this, the triumph of science is not, the genius of all this stuff is not, it looks like it's genius because it's so complicated. It looks like it's brilliant because it's so elaborate, like only a genius could come up with this. No, the genius is, this is the simplest possible, this is the least insane way that we have come to find that works to describe the insanity of actual reality. Like, the insanity is not these freaking lines. The insanity is that the sun apparently pulls harder when the earth gets closer to it. And what we're all saying as human beings is, how can we, never mind how that actually works, how can we even picture what's going on in a way that we can make sense out of and live with it? And what we're trying to do with these field lines, or any model in science, we're trying to come up with the simplest, most sensible, most reasonable model that can actually capture what's completely unreasonable and unexpected about reality. So of course, I'm just saying again, if you don't like this picture, not just the private chat person, any of you, I didn't like this picture for years and years. It seemed like craziness to me. And it seemed like a bunch of scientists just trying to be all nerdy and cool and come up with something too hard for me to understand. What I understand now is, if I come up with any other picture on my own, it's going to be worse, not better than this. Like that, and that may not be true for you, but my pictures are going to be, what's genius about this is how simple and reasonable it is in relation to the crazy reality that's going on, which is this. And I know I have 2 minutes, but I'm going to leave you again with this. The real question that I need to answer for you by the end of this semester, in the hour and 17 minutes that I have left, including Monday, is, wait a minute. This whole thing was motivated by the fact that when the earth moves, the sun gets that update. Can I explain to you guys in an hour next week, and can I test you on what happens to these lines when there's an update? That's the last question of the course. That's the thing. I was going to say more about it today. I won't. I'll say it all on Monday, or maybe I'll put something in Google Classroom. But just so you know where this is going, I want to know when one of these protons moves, how, like, what happens to the lines? How do the lines adjust and convey the new information? How do we send updates through the lines? If I could really answer that, then I'd really have a good reason to hold on to this line picture. The thing that motivated the belief in the lines in the first place was the knowledge that somehow these lines allow updates to travel back and forth through them. And that's what I want. So what I want to answer by Monday is, what does a mental picture look like when an update is sent through the lines? If the lines are like a medium, if the lines are like information itself, then what does an update pulse look like in this picture? That's the point. That's what I'm going to tell you Monday. That's what you're going to tell me back Tuesday night. And if you think it's a little bit weird, yes, so do I. The universe is a little bit weird. But if you, by the end, see the possibility that it's weird in a beautiful way, then I hope to see you again on the path. That's fine. Okay, so I'll see you. So I owe you everything, including the universe. I appreciate the questions very much. I'll try to send you stuff this week, blah, 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 blah. I will see you. And you shouldn't be doing anything except if you find anywhere you can get more points out of the class, just hand them in. But there's nothing to study or anything like that. Okay. And get to know, if you've missed classes, try to get to know, because some of these questions, some of you, maybe some of these questions are actually answered if you weren't in a certain class and there were actually notes on it. But okay, goodbye. Have a great life weekend. Thank you. Thank you. Have a wonderful. Yes. Okay. Oh my goodness gracious. Thank you guys very much. Turning ceiling. Thank you very much.